So, in the next installment of our Chapter 9 discussion of orbitals, we had talked previously about what the orbitals were. These are spaces of probability where the electrons can possibly be found. So, there's about a 90% likelihood of finding an electron in the space. Using these complicated wave equations, the scientists have calculated the shapes of what these orbitals would look like. So, the next video, we are going to be talking about the different shapes and types of orbitals that have been predicted using these calculations. So this next slide lists the types of subshells. So remember, we talked about levels. So these initial primary quantum number, which would be the level equivalent to the Bohr model, which talks about level ones, two, three, four, five, right? So within that, you then have a subshell. And those subshells have specific shapes. And I know this is confusing, but we'll draw this out in more detail. So imagine you have for each level, you have the potential to have a subshell, which is just these sort of shapes that are underneath that shape. So your different types of subshells can be spherical. So an S subshell has a shape that is spherical. Think of it like a tennis ball or a billiard ball or something, a very simple spherical shape. Each level has a S shell. So starting at level one, primary quantum number one, you'll have a 1s, a 2s, a 3s, a 4s, a 5s. So those are a shape of subshells that will happen at each particular level. The next type of subshell would be a P subshell. And those are going to look like a dumbbell or potentially two balloons tied together. And we will see pictures in the next slides, but this is just giving you a brief overview. At the P, within the P subshells, there are three different types of P subshells. You have X, Y, and Z, and they alternate. Again, you'll see those pictures. You do not get your first P subshell until level two. So there's 2P, 3P, 4P, 5P, etc. The next one is going to be D subshells and F subshells. These are much more complex structures, and I will show you some pictures of the D, but these are not things you're going to have to remember at this level. They have been predicted using the calculations. What you're going to need to know is that they exist and how they will fill. The shapes of them particularly are not something we're going to talk about in the scope of this class. But as you can see from this chart, your first S shell would be at level one, your first P shell would be at level two, your first D shell would be at level three, and your first F shell would be at level N. I will again be explaining to you how you will be using these. This is information you'll be needing eventually. So for each S shell, you would have one type of orbital. You'll have one sphere. At the P subshells, you're actually going to have three of them. They're going to be in the X, Y, there'll be balloons tied together in the X, Y, and Z axis. When you get to D and F, they're much more complex, but you'll just need to remember that you have five orbitals at the D subshell, five different types of Ds, and seven different types of Fs. And we're going to use that information moving forward. Okay, so this is just an introduction to the types of subshells, and let's take a look at what they look like in more detail. So this is very confusing. Don't worry about it. We'll be going over this a lot more, but I just wanted to introduce you to the concept. Okay, this just explains to you, this is just a graphical explanation of what an s orbital is. Remember, these are the smallest and simplest. These are the ones that you only get one per level, and they're spherically shaped. Thing to remember about these, they look like a sphere. These represent the probability of finding an electron. So if you look at the bottom left corner and you see that dot diagram, that represents the possibility of where these um, electrons might be found, right? So it's not exactly perfectly a spherical shape, but it sort of represents the idea of where you might find an electron. The difference is as you move up in the level, these spheres get larger. So they just become, as you realize, the levels of orbits become bigger, right? Level one orbit, just like the Bohr model, level two, level three, these get bigger orbits, as does the S orbital. If you can imagine the simplest way to imagine an s orbital, it represents the space at that orbit. So it's the simplest orbital, and it's very similar to that Bohr model, where if you imagined that Bohr model was three-dimensional, it would fill that space at a level. But these are fairly easy to visualize. They get a little bit more difficult to visualize as you move up to the different types of orbitals. So just remember for now that you at each level you will have a 1s, a 2s, a 3s, and a 4s. And so they will get bigger depending on how many levels you have. Okay. Now we get to the p orbitals. These are fairly easy to visualize as well. We talked about these being a dumbbell or two balloons stuck together. This again shows you that you will have three different shapes, three different orbitals at each level. So for These start at level 2, so you don't have a 1p orbital. You only have a 2p, 3p, etc. But let's just say, for example, at the 2p level, you're going to have a px, a py, and a pz. Each of these p orbitals can hold 2 electrons. And just because you see the 2 lobes, don't assume they're necessarily going to be one in each lobe, but it does draw to you the concept is that the electrons, 2 of them, will be found somewhere in this space. Yes, I know this is a very complicated concept. What you need to take, I will explain to you as we get through all this background, what you really need to know. But this is just to help you understand where these are coming from. As you move up to the larger orbitals, you're going to find, there we go, the d and the f orbitals. So I just, here you have representations of the d orbitals. And as I said, you had 1 s orbital, 3 p orbitals, and then when you get into the d's and the f's, you would have 5 d orbitals and 7 f orbitals. We've shown you the picture of the d orbitals, and as you can see, they're much more complicated. You have the dx, xv, xy, X, say YZ, X, what. Anyway, the point is, I'm not even going to try to explain them. You do not need to memorize the shapes of these at these points. You just need to know that they exist, and that these structures become much more complex as you move up in the orbitals. The F are actually even more complicated. Um, but for what I will ask you to remember for me for an exam would be the shape of an S or a P, being the fact that the S is spherical and the P is that dumbbell or balloon shape. These other ones you will not be expected to be able to draw or remember the shapes. Just know how to use them. Okay, this summarizes for you what we just talked about in terms of the orbital shells and subshells. So remember we talked about shell number or the primary orbital number, or sometimes just level number, right? So those levels, the shell number n is equivalent to that Bohr model concept of each orbit being at a different level. As you what makes the quantum mechanical model so much more complicated is you can't visualize that within each level you have these imaginary space that has these individual subshells or then subshell orbitals with different shapes that are confusing. So as you see that each shell has an increasing number of subshells, up to 4, and then everything past 4 will have the S, P, D, and F. So you'll need to use that information. So this chart right here will be very helpful for you when we start talking about the next concept, which is to fill the electrons into the individual shells. So what you're going to need to know, and this is where we're headed to what you really need to know and how to use it, is we're going to be taking the individual elements, and we're going to be figuring out how the electrons will fill these particular orbitals. The next section, we're going to talk about the rules of how, but we've talked about how to determine how many electrons each individual element has based on whether it's neutral or an ion. You would then count the number of electrons and you would fill these based on the levels that are there. And there are rules for that, but that is where we're headed in the next section. So taking away from this particular video, I want you just to understand this particular chart is what you'll be using. How many electrons will you have per shell? How many orbitals are per shell? And how will they fill each shell? So if you can reference this particular chart as we start learning how to fill those electrons or fill those orbitals, this is what you'll be using. Okay. Jumping into the next section, I'm going to stop this video and we will then be talking about the rules for filling orbitals.